So, welcome to building serverless application with Azure Function. My name is Yohai Kiryadi. I'm a program manager working with Azure. I've been working with Azure, Azure App Service, Azure websites, if you're familiar with, for the last 5-6 years. So I've been with the project pretty much from the first day. And about 10 months ago, we started Azure Functions, so it's very exciting, and that's why I'm here. My team blog a lot on MSDN, on Microsoft.com, on the App Service team. If you want to follow me on Twitter, sometimes we have some interesting conversation about functions or App Service or cloud in general, serverless, and that's my email if anybody wants a more personal touch. All right, so we'll talk about, hey, what's serverless? Then we'll see how Azure Function, introduction to Azure Function that basically is serverless compute, and then we'll explore some actual customers, real-world examples, patterns, stuff that's happening with Azure Function. At this point, I would like to ask, who is using Azure Function already? I got 2 people. OK. You might get bored for the first 20 minutes, but everybody else may not. So this is the point where I'm actually going to tell everybody, if you want to follow up the demo, follow up with the demos, you can pull up your laptops and go here. I'll show you what's in here real quick. AKA try functions. Right? You'll end up here. If you have an Azure account, you can just go to the portal. If you don't have an Azure account, get one. But if you don't have one and you actually want to follow up for the first couple of demos, you can definitely do it through here. So I'll let you guys set up with this, and I hope you don't going to get too much distracted with everything else. So let's move. We'll set up the stage. We'll talk a little bit about the different compute options in Azure, or kind of how do we see them. So let's say your app is a car. Most of you probably own a car. So the analogy we're trying to make is basically for owning a car versus using taxi or Uber services versus renting a car. With respect to IaaS, which are VMs, Uber, which is basically SaaS application, or platform as a service, which is what App Service is doing or what Function is doing, which is kind of renting your car. And that's kind of the idea. The idea is that if you own a car, you need to buy it, finance it, maintenance, change oil every now and then, do all that kind of stuff. If you go all the way to the side, if you use Uber, basically just use it. Maybe you're paying premium for that instance of time, but you don't have any responsibilities. If you drive a car, if you rent a car, basically you can rent it when you need it and get it and then return it. You do need to fill up gas, for example, but you don't do anything on the maintenance, you don't care for financing the car and stuff like that. That's kind of the analogy. To be more specific and going to a little bit more details, this is basically just a question of trade-off in between what do you want to do, how much control do you want/need, versus how much do you want to be, I would say, more productive or less bothered with actually managing infrastructure. So if you're on-premise, you do everything, the entire stack. When you move to IaaS, VM scale set, basically the cloud provider will give you all the abstraction, but you still need to manage the OS, patch the OS, bring up the middleware, the runtime, and all this is even before getting to the application. And then comes platform as a service, which basically allow you to just write your code or manage your code to a certain degree without any of the other interaction. And SaaS is basically just a service. All right. So with that in mind, Azure App Service provides a fully managed platform. And within that, we got web apps, mobile apps, and API apps. We had Azure App Service, Azure websites for quite some time. Anybody is using Azure App Service, Azure websites? A little bit more. Oh, OK, better. Cool. That's good. So Azure Function basically runs on top of Azure websites. So a lot of the stuff we're going to show you, for those who raise their hand, I hope we're going to be familiar with. All right. Cool. So why serverless? There is a single slide, but I'm saying, hey, why can I need to talk for 5 minutes on a single slide when I can do basically a lot of animation in between? So before we had the cloud, if you wanted to run something, basically you need to have physical servers somewhere. And you build your application and data on top of that. Usually, those were either on-premise or in colo. And then you'll be able to connect through internally, externally, whatever you want to do with it. With that, basically, before the cloud, there was a gazillion of questions that you need to basically answer when you come to provide such a solution. Stuff like, where do I buy the servers? How long does it take to provision the servers? Anything from physical access, electricity, networking, backup, bunch of questions. Quite messy, but this is so 1990s, I guess. Anyway, after that came IaaS, right? Where you actually go ahead and get a VM in a cloud for a cloud provider. And with that, a lot of the questions basically go away. So how long does it take to provision the server? It really doesn't take any long to provision the server because you basically get it within a couple of minutes on a cloud provider. What happens if there is a server hardware failure? Well, again, you don't really care because basically you'll be migrated probably automatically to a different server. And then you can see it's asking a question about physical access, question about backup. All of those questions kind of go away because you don't really own the infrastructure anymore, which is good. And then come PaaS. And with PaaS, we actually can eliminate even more questions, right? So using AppService or website, those who raise their hand, know that basically you don't really choose the OS because we already provisioned it for you. You don't manage the OS. You don't need to patch the OS. You don't need anything like that. You don't need to patch your servers. You don't need to package anything on the servers unless your own code and any binaries basically or assemblies that you want to bring with you because we manage the entire infrastructure for you. We manage code deployment for you. We deploy it across multiple servers, not just one. If you have 10 virtual machine, VM scale set or IaaS that you need to actually manage them, then you need to go ahead and deploy to each one of them. There's automation, but you need to do it. With platform as a service, all of this is being managed for you. And there is more, basically. But even that, you still have several questions like around basically how many servers do I need, when the utilization, whether you scale up, down, all of that. And the platform does take care of that for you, but we can even take a step forward and introduce serverless. And with serverless, basically, we take away the questions of how many servers, what's the size of the servers, and the server utilization. Because basically, serverless means that we'll give you as much compute as you need when you need it. And then the only question that remained is basically how do I scale my app? And with the serverless in particular, it's not necessarily about scaling, it's about architecting for serverless. And we'll see some examples during the presentation. All right. So what is serverless? Basically, serverless is an abstraction of servers. As you've seen, Azure App Service is a fully managed platform. We basically hide all the infrastructure behind, and you don't really care for anything that your application runs on top. You shouldn't. If you do, then we need to have a conversation whether serverless meets your need or not. It's event-driven instant scale. This is very important. Basically, it means that it reacts to event, and we'll see some examples. And when there is events, we'll basically give you compute to run. And if there are a lot of events, like many events, we'll give you a lot of compute to run. But when there are no events, we'll basically take away, and you have no compute that you need to use. And that introduces basically a sub-second billing because you pay only for the time that your code runs. So you don't need to rent in advance servers and keep them somewhere or in the cloud or use whether they are being used or not even a single server. And only when there are events to be processed, basically, we will kick in your application, your functions, and you will be billed only for that time frame. What does this give us, basically? It reduces our DevOps by a lot. Doesn't mean that eliminate them. There is no such thing as eliminating DevOps, but it reduces and allows you to basically just focus on the business logic. You now can focus specifically on what you need to do on the task at hand. There are no more managing of VM infrastructure, of understanding how it works, how it is deployed. Basically, you write your code. I can show you several ways to do it, and then it runs when it runs. And all of this reduces time to market, faster iterations, all that jazz, which is good, I guess. OK, so we've been talking for about 10 minutes. Let's see if we can get to some demos after this slide. So here comes Azure Function, which is serverless. Azure Function is a serverless compute, event-based serverless compute. You can develop with JavaScript, targeting Node, C#. We added F# recently. It's not on the slide. basically there are additional languages. I'll show you in the demos. And the cool thing about it, you can also run and develop them locally, which is kind of nice. And there is an interesting aspect of binding into other services, whether they are Azure services or other external services. And it's easier just to show a demo than talk about that. So with that in mind, let's actually see a demo. This is where I encourage people to try and follow up. So this is the try, but I'm not going to go here. I'm going to go to my actually function. So this is my portal. I already created a function because it takes about 30 seconds, and they want us to like twiddle our thumbs and figure out what to do here. So this is an empty function. So if you go on the plus sign, just really quick, and create a Azure Functions, you'll see give it a name, a subscription. There is consumption plan on app service plan. We'll touch it in a second. Once you create it, as I said, take about 30 seconds, and you basically have a function app ready. Once you have a function app ready, once you log into it, you'll see this screen, which is very similar to the try screen. And I see a few with laptops. I hope you're following. And basically, what we're going to do is we're just going to create a new function. And as you can see, there are multiple languages options here. We'll start with just, say, JavaScript, just for the sake of it. And we'll use HTTP trigger to show how things can work. Let's call this demo 1 because we'll have multiple. Let's leave everything else for default and hit the create. This will basically now create a function within the function app. And as soon as it finishes loading, I will actually show you how it looks like. So basically, this is it. This is all that it took to create an HTTP endpoint working in the cloud. I'm going to do this so it'll be a little bit easier for us to follow. Zoom in a little bit. OK. Cool. So basically, this is it. This is the endpoint that I got. And it basically says, hey, I need to pass a name. And if you look at the code specifically, you can see, is the font OK? Can you guys at the back see anything? Yes, no? No. Let's see if this works, although I'm not sure. Hopefully. Better? Yeah? OK, thumbs. I see some thumbs. OK, so basically, it's a JavaScript code. If you're anybody who wrote an Express app, knows this, or is familiar with the code, sorry, or with the structure at least. You can see it requests a query parameter. If it's not, then basically returns a 400. So basically, let's add a query. And let's say, hey, and name equal Chicago, because we are in Chicago. And it says, hello, Chicago. Yay. See? That's how it is. Let's change it a little bit. Welcome to Chicago, and then we're going to add here Tech Summit 2017. Hit the save button. Go here, refresh, and that's it. And this is how easy it is to create a function, an HTTP endpoint in Azure Function that everybody can touch it now. And work without. And you can imagine what else you can do with this. And I'm going to walk through some of that in a second, basically. OK, so quickly, let's go back to the slides. What we've seen is in Azure Function, we have triggers and binding. And essentially, a trigger is something that invokes your function. As I said, functions are event-driven. So a trigger is the event that invoke your functions. We have seen the HTTP one. It could be REST or webhook in terms of options. We got scheduling, which is a timer, basically. And you can trigger off few Azure services, like storage, queues, and blob, and event hub, and service bus. And we're adding more and more into the triggers. Essentially, any trigger in Azure Function is basically an input binding. And as you can see, there are multiple output bindings that we can use. And this is just a partial list. You'll see actually more when we go through the demo, which allows you an easy way to interact with those services. OK, so let's go quickly through the programming model and then see a demo of the binding that will make it a little bit easier and simpler. So function programming model has a nice programming model, very easy to follow and use. We've seen this code. It's almost identical. This line is a little bit different. So basically, what we've seen is we have a trigger. as I mentioned. And there are multiple triggers. And we'll see a queue trigger in the next demo. And once we have a trigger, we have contexts. And the context basically represent, in this, for JavaScript, represent both the input and the output. And you can see here, I use it as an input with bindings, and I use it as well for the output for the return value. And then I have bindings. And bindings are those things that basically help me communicate and work with other Azure services or other third-party services without really need to know how to work with those services. Specifically, in this example, as you can see, binding are basically a JSON object. They're declarative, which means you can take them into your DevOps and parameterize them and do a bunch of stuff. You can see there is a direction input for HTTP trigger. This is my trigger. There is output, which is return. This is fine. And then you can see here there is an input parameter for, and this is specifically for Azure Storage. I define a table name, which is actually Azure Storage table name. This is the input parameter to work with. And then you can see here it's a connection. It's not really a connection string. Where's the mouse? It's not really a connection string. It's a pointer to an environment variable that lists a connection string. And the cool thing about it is here is binding.inputTable.name, and I do not need to know how to use Azure Storage SDK to actually get to the table. Cool? All right, we'll see example, make it less easier. With C# is basically similar, but the C# binding model is a little bit better, stronger than the rest of the languages. And basically because this is best of web jobs, if you're familiar, but there is a slide about that later. So in this case, there is a trigger. There's multiple inputs that we can have. And within C#, a function looks like any regular functions, right? You would expect to have input parameters on your function to be able to work with in your code. That's exactly what we're giving you. We're giving you input table in this case, which is iQueryable, basically allow it to iterate. And you can see here there's a specific class I can work with. All of this happen automatically within the binding to allow you to basically work with the binding and with the data as you would expect with any regular function. Obviously, output parameters that are available, binding declarative again, and you can see I can work here with the code and work with the input binding and just use code as I would expect. Okay, so let's basically just see how things are actually working. And for that, I'm going to go back to this application, and what I'm going to do is this. So before returning a name, I'm going to do the following. And I'm writing in JavaScript, but the next function will be C#, so no worries if anybody doesn't like JavaScript. By the way, I don't. But hey, a lot of people do. So let's create an object called foo, and basically what we're going to do is we're going to go for query name. So we're going to go for request query, and we're also hopefully going to have a foo object on top of that. And if we basically don't have one, then we're just gonna create a default to basically say foo is empty. Okay, and obviously here comes bar as expected. So the same treatment with bar. Here goes bar, and basically I'm gonna say bar is empty. And now I want to basically take this message and put it in an Azure queue. To do that, I need to do one more thing. And I'll do it now. So I'll go to the Integrate tab over here. Integrate tab is, I'll show you really quick behind the scene. This is the JSON that we've seen. And the UX view is basically just a nice editor to allow you to work with bindings, just to make life a little bit easier. So as you can see, I have a trigger, HTTP. I don't have any inputs right now. I didn't define any inputs. And I have an output, which is HTTP as well. I can add another output. And this time, as you can see, there are a few output options here. There are a few output options here: Azure Services, Blob, Storage Queue, Service Bus, Tables, Mobile. You can see external third party like SendGrid and Twilio, which we'll see a little bit later, the bot framework, and so forth. So this is behind the scene, all the bindings are extendable. We are working on a model that everybody can contribute. But for now, we're just adding services on our own. For this demo, we'll choose basically our storage, Azure Storage Queue. Go ahead and select. And once I select, I drop here. And this is a parameter I'm going to work with. I'm just going to copy it. We are going to I'm going to write to a queue, Azure Storage Queue called output queue. I'm not going to change anything. If you can put any name here that you want, which is a valid Azure Storage Queue name. If it doesn't exist, the system will create it for you. There is a connection string here. With every Azure function we create, basically we create a storage account. So I'm just going to use that as well. I'm going to hit a save. Some cool things about this interface, as you can see here, there's a little plus for documentation. A few tricks. First, you can get your storage information here. But this actually tells you how to use that binding that you just used, just like a quick reference. OK, back to the demo. So the only thing we need to do here now is basically say context and dot bindings and the name that we have copied. And I will say message equal this, and that's it. And this is basically writing message to Azure Queue. No SDK, no need to know how to work with Azure Queue and how things work behind the scene. I hit the save. We go here real quick. We'll refresh, and that's it. We have one item in the queue. Hooray. You can't really know or believe, but trust me, it's there. And I'll show you in a second anyhow. Now, instead of going ahead here and writing, adding all the parameters, we have some cool stuff you can do. There is a task tab over here. And if you're familiar with Postman, it's not Postman, but basically it just helps you to basically really test very simple HTTP APIs. You can choose the different method that you have here. Those are the query parameters. You can add queries. So obviously we need to add, we need to add name. I'm going to leave it with Chicago just for good luck. We have foo, which is great. Let's call this is, you know the rest, right? Here come bar with this is a great demo. This is where you're supposed to laugh. Yeah, that's okay. At least a little bit. And then I can highlight my logs for real quick. I'll clear them. This is because me trying to zoom in, strange things happening on the portal. Let me try to do this. Didn't help. But I can run it, basically. It runs. Here's the information. It's successfully there. Again, it's in the queue. You guys need to believe me, but instead of you just believing me, I can show you a few things. First, you can pop into Azure Storage Queue. Azure Storage Explorer. If you're familiar, it's excellent. I think I am running on this one. Queue should have two queues here. Here is one, and here are the two items. You definitely can see that size, but here I'll try to zoom in. And you can see, obviously, the first one is empty, and the other one is bar and demo, which we expect. So we know it's there. Let's see how easy it is to get it out from there. So let's create a new function. This guy will throw with C#. We'll go with the queue trigger. Application, function, we'll call it demo2 just because we can. We copy this. Doesn't matter. All right. And as you'll see here, hopefully, really quick on the logs, you'll be able to see that we're already dequeuing. We're supposed to dequeue items right now. Ta-da! Nope. Failed. Looking at the wrong place. Ha, the queue item is not the right queue. We're looking for out queue. So basically like this, out queue, save. Hopefully this will save the day. Ta-da! Here are the items, really quick. You can see here is foo is empty, and here is foo. This is a great demo. All right, this is where we clap. No? No, you really don't have to play along with me, seriously. OK, but we are not done. We can do some cool stuff because now we are in C#, and C# allows you to do some nice, cool things. So let's go with public class Poco, right, as you would expect. And let's create a public string called foo, obviously, with get and set. Do the same thing with bar. So far, so good. So the next thing I'm going to do is I'm going to basically take Poco, and instead of just working with strings here, I'm going to actually do it with a class. Again, as you would expect when you write real code, or real code. This is real code. Sorry, ignore that. Okay, bad me. So this is Poco, and what happened is the binding will actually take, and we'll try to do the conversion, and we can see, I mean, obviously you can experiment with it a little bit, and you'll be able to see if things goes sideways or not. I'm going to clear the logs for real quick. I'm going to save. And saving, you'll see that actually ran compilation and compile success. So every time we actually run compilation, because it's C#, and if there are errors, you'll be able to see the errors. And we are improving this in interface, so we'll actually be able to see better results or easier to work with the compilation process. And as I mentioned, we have Visual Studio tools and CLIs. If we have time, I'll show the demo, just an introduction, but it's there, and there are videos, so we can definitely work on that. And you can run this locally. We'll see it in a second. Okay, so Poco. So run a Poco, run a number, and this is from a different application. And at this point, basically, when I'm going to go here and run this, you'll see that it got printed, but this is basically kind of funny printing because I don't have anything here. So we can basically go ahead and create a public override string to string and create something like this.foo plus horrible code, but for demo works, this.bar. Okay, we'll hit the save, and again, we'll go here, compile, failed. Why did it fail? See, thank you guys. All right. I'll hit this. And here it is. Foo is empty and bar is empty as expected. So let's go ahead here. And I can add the names and all that, which is great. But basically, query parameters are working fine. But there's additional actually other stuff you can do, like API routes. So let's go to Integrate tab here on the trigger, which is HTTP. If I scroll down a little bit, there are a few parameters here, like the request parameters you can change if you want. You can choose specific method, as you can see, and this is where allow you to actually create a real API interface. You can change authorization level. We have multiple keys. You can change them, work with them. We're not going to change any of the defaults right now. What I am going to do is basically just add a route. And I'm just going to add /foo and have a parameter and /bar and have a parameter. And as soon as I save this, if I go to the develop, you'll see that basically this endpoint now has changed. And now I have my API, which actually looks in foo and bar and so forth. And this is rather cool because the curly braces for foo and bar will actually give me the object itself that I can work with. As you would expect when you go ahead and write code. And I never remember by heart what do I need to write, so I look at my cheat sheet notes. Okay, binding data. So basically what we're going to do is we're going to, this is not as standard as we would like. So basically the object hangs from context dot binding data. And from here, everything is basically the same. So we go just the same thing. Instead of request parameters, on the query parameters, we just go with the binding data because we do the binding for you. So we intercept the route, understand it, translate it, and basically augment it into this. And now you have those parameters right here. We're going to stick with the other names as well, just to make it easier. So we're going to go here real quick, copy it. This one does require a little bit of massaging. So here is foo. Cool. And this is demo. Demo. And add name. I got 2 names. Oh, I already have a name? Perfect. Good. So I don't need anything else. All right. Even better. Ta-da! Boom! This did not went as expected. Oh, there's multiple of those. Sorry. I forgot to save it? Really? That shouldn't explode, though. But I think I just made a copy mistake on here, so I'll do it again. Okay, and now I don't have name. I'm not supposed to have name. Let's add name. You guys are really helping me, so this is cool. Thank you. Cool. Demo. Hopefully. Ta-da! Yay! Yeah, so this works as expected, kinda. Go to the develop tab, and this is a cool demo. And I can do more. I can actually go here and says, like, you know what? Instead of a string, let's make it an int. I'll hit the save button. I'll go over here, run this again, and now it's going to explode with an exception, obviously, as you would expect. And the exception says, hey, we can parse because whatever you pass is not an integer. So you can see the power of how this thing can work and how powerful this thing can be with respect of quickly iterating, building. This is just an API, put it in a queue and do something with it. Towards the end, I'll show you like a little bit of a more interesting an example that you guys can participate in. And later I'll show you definitely a bunch of customer examples, and I hope that will go well. So this was chaining queue. So what do we got? We got basically the serverless aspect, right? I'm writing code. I didn't create a server. I didn't deploy anything, and it runs, and it works. So this is where serverless compute abstract away all the compute. However, the binding, as you've seen, abstract additional layer from me, right? I don't need to, in this case, I just work with queue. There's another demo I'll show you how to work with DocumentDB. But that's it. I didn't know even, I mean, I know there is a queue behind the scene, but I don't know how to work with the queue. I don't need to use the Azure SDK to work with the queue. So there's a lot of scenarios in which just abstraction saves a lot of time and makes you a lot more productive. So how this thing works, basically. So Azure Function Architecture, I'll go quickly on that. But the reason I'm showing this slide is just to understand with the different layers, but actually talk to the fact that we have been building this infrastructure for basically 6 years, give or take. So the app service infrastructure, the bottom line is the thing that runs your Azure website and Azure App Service. And if you have a mobile application, it's the same thing, if you have a mobile backend. And if you have a API app, it's the same thing. On top of that, we have the web jobs. Web jobs core is an extension. Web job is being a solution that we have been pushing for 3 years. It's a very used feature in Azure App Service. Basically, it's allowed to run async processing, background processing. And this is the runtime or the heart of the thing that runs functions. Extensions allow you to do all the triggering, the runtime on top of that. This guy is basically just allowed to, is the host to run the dynamic, or where you can write your application and do all the magic, languages, and you can get code and config on top of it. You get the idea. A lot more documentation if you're really interested. The nice thing about the whole thing, it's completely open source. So the entire Azure function stack, up to the core fabric, basically up to this little thing over here at the bottom, is open source. Sorry. So if you go to GitHub, Azure Functions, and this is it. This is the project, and it's out there in the clear. Everybody can work it out. You can see there are additional repos here, like the runtime, the command line interface, which allow you to run function locally and debug them. The portal itself is open source. All the templating around that. We have ability to file issues. We accept external contribution. Sorry, so far we have about 20 external contributors that are not Microsoft. Obviously, the main contributor to this repo is our team. Beyond that, we have externals. And if you have any issues with documentation or anything like that, you can easily go ahead, file issues. You can see there are a bunch of stuff happening recently. And those are the additional repos that we have. Oh, this is actually a bug. This is the SDK itself and so forth. So you get the idea. Open source, nice community. everybody can work on it. Okay, so really quick about scaling Azure Functions. Azure App Service offers dedicated and consumption tier. The App Service regular model offers you free and shared, which are multi-tenant, basic, standard, and premium, which gives you your own infrastructure, your own VMs basically behind the scene. But you need to set how many VMs you want and how to auto-scale them and all of that. You pay for those VMs, whether you use them or not, and it's, as I said, it's your responsibility to scale. On the consumption, which is what I created on Azure, where I created this app, basically you pay only for the number of execution, and the platform will scale you as needed. And basically how it works, there's a new unit called gigabyte per second, and basically number of execution times the memory that you are using. So this little app that we've seen probably uses what? Maybe 150, 200 megabytes, and it runs for fractions of seconds. And the unit here, the gigabyte per second is $0 and 4 zeros and then an 8 or 16 or something like that. So anyway, it's ridiculously low. And you pay only when actually you're doing work. So that's kind of the thing. All right. So with that in mind, what I want to show you now is a little bit more interesting demo in terms of how you can integrate non-Azure services with Azure services, a little bit more complex example. Yeah, let's show you the demo, and then we'll do the interactive piece to it. So for that, I think I'm going to go over here. Yeah. All right. So what I have here is a demo I wrote. I created everything in the portal. It was OK. Definitely the next one, I'm going to use the tools. A lot easier to work than the portal. But as you can see, you can create quite some extensive code coverage in here. And a bunch of stuff. So what this thing is doing is this. I got an HTTP trigger here, which basically is a hook. The demo is you guys will take up your cell phone, send an SMS, and to basically the Twilio service, and Twilio calls this function with the payload. I take the payload. I do something with the payload. Basically, I break it apart. I compose a new message. I get all the information that I want, and then I save it to a queue. Cool? That's it. And then I respond basically to Twilio saying, don't reply to the SMS. OK, the next step is I'm going to run sentiment analysis on those stuff. So few things to look in this, and this is where I want to actually pay attention. So what do we got? You can see #R here for referencing an existing assembly, newtonsoft.json. It's something that actually we bring on the platform, so you can just use it. You can see here I'm loading additional class shared libraries. I'll show you what those shared libraries is in a second. And you can see here I'm just regular using Newton for the JSON, Newtonsoft for JSON, and then I'm using Project Oxford, which is Microsoft Cognitive Services. Okay, I use Cognitive Services to do the sentiment analysis on the string of the text. It's a queue message. Remember, we pushed in a queue, and I'm going to get the actual object because I know exactly what I put in. And then I'm running, this is a pattern that we are looking to adopt and maybe create a default try-catch for the operation so you can actually manage and handle errors. Again, everything is asynchronous, so you need to handle that on your own. I'm going to update, basically this function goes ahead and do work for me. Sentiment document is from the Project Oxford, it's data reference assembly. I'm going to create a request. Basically, I'm going to show you, let's do it right now. This is an environment variable. I'm going to get the key. I don't want to put the key in the code, obviously. So if I go to function setting real quick, service editor, we'll see the configuration. So again, if you're familiar with Azure App Service, this is not new. What you see here is the configuration for app settings. And you can see I get a bunch of settings here. Some of them are default, like storage information for the function, the runtime version of the function, all of that. But here you can see I have two variables that I have defined basically as a reference to hold the secrets because I don't want to put the secrets in code. And within the binding, what we do is basically just reference those, which is exactly what we're doing. Sorry, here. All right, and then basically I just go ahead and run the sentiment analysis, get the score, move on, and then I'm going to do a send response. Send response, I want to show another thing. Oh, actually, you know what? No, wait, I have to show it here first. Sorry. Okay, so sentiment analysis uses Project Awkward. Project Awkward is not deployed by default on the runtime. What we have here is the ability basically to define project with the project JSON, again, standard. This is like an entry if you would, this is basically how you define to bring in additional references. So this is going to NuGet, and we'll get your package. Again, we'll do it automatically for you as soon as we detect the project JSON. So you can bring any NuGet package, you can bring your own assemblies, you can load, all of that works just great. Let's actually go back to the code. And I can load shared assemblies. The shared assemblies are also something cool. If you go to your app setting, there is something called App Service Editor. And App Service Editor is something that, again, we had for quite some time. It's basically an online editor that allows you to show your entire web application. As you can see, there is, under www root, you have all the functions that are being defined, like the webhook that we've just seen, for example, and so forth. And if I scroll all the way to the bottom, you can see my shared folder with my actual classes that I use. So this is just the class definition so everybody can use, and a simple utility to get the environment variable. All the environment variable, the app settings are basically being set as an environment variable. Okay, this is going too deep for introduction. Let's just go real quick. So the send response is another cool thing because I'm using Twilio. And you can see I'm using #R Twilio. I'm not referencing anything. I don't have a NuGet package here. And the reason I don't have that is because specifically for Twilio, we added them as a binding. And you can see I got Twilio here as a binding. There's some information on the Twilio account, seed and setting. These are the parameters. I don't have to fill all the information. I actually overwrite this phone number from Redmond. And I also have a DocumentDB because I can push this information into DocDB. So now what I'm going to do is I'm going to go back to develop, show the log in the clear, go here. And I'm going to tell you guys to pull up your phones, right? Real life demo, high stakes, and tell you to send here, what do you think? What do you feel? What do you think about Azure Functions? What do you feel about this demo, this session, this day? And let's see what happens. Maybe I should do this before showing the demos, but anyway, we'll see. Let's see how this goes. You can see it looks like feeling great. This is good, I guess. So more information coming in. This is cool. All right. So you can see the logs are coming. You also get response, I hope, right? Who got response back? Only one, two? I hope all of you got. What's the number? Oh, sorry, what's the number? Here's the number again. It's a local number, right? I just created today. I don't know. All right, so 2 more seconds. Got it. So as I said, I push stuff into DocDB, and DocDB is pretty cool. And what we're going to do here now is we're going to just run a real quick querying. Actually see, let's say we're going to take only the guys that actually had good comments. Otherwise, why even bother? What do you want? What? All right. So this is it. This is I think these first few are mine, maybe. Cool demo, yeah. These are already not. These are more. This is you guys. Thank you. This is good. You can see the data coming in, IDs that I created. DocDB allowed me to augment some of the information. I'll show you the entire packet in a second, but it's pretty cool. But your t-shirts is on point. Yeah, good. Thank you. And you can see all of that. So this is cool. Scale, all of you got information. And this is, again, no servers behind the scene. I haven't literally, didn't manage anything other than just create some JavaScript code, a very simple select for this, and a little bit of code over there. If you want, I can run this one, the whole thing. And this you'll see basically, this is like everything. So I'm saving a lot of information, as you can see, like who sent the information, phone number, where did it get from, all the data, timestamps, the original data, and all this information. So I can now, then everybody, I got everybody's phone number now, I can bug you. Nah, not really. All right, I think we've seen that. This is good. We're doing good on time. Okay, so we've seen this demo, and this is awesome. So now what I want to show you is basically use the next, let's say, 10, 20 minutes to talk about serverless patterns, some real-world examples, and share some actual customer what they're building, and then we can have any kind of conversation if you want. Cool. So first scenario we're going to look is, hey, something happened or someone, magical way, placed a file in a blob storage. And basically you want a function to pick it up. In this example, in this demo of the animation, we take it, we break down the CSV, we put it in a database, in Azure storage table, doesn't really matter, and we run some analytics on top of it. All right. So the example I'm going to show you is a person called Troy Hunt, Microsoft MVP, good friend. Basically, he's a security guy. He has a security site, and his good buddies are trying to hack it all the time. And basically, he needs to protect against DDoS, and it's a kind of game, weak, sick game they're playing, I'm not sure. So basically, what they're trying to do is trying to protect against DDoS, and the thing he's wanting to do is dynamically configure Cloudflare. He has Cloudflare in front of his website. And he already has an existing application running. So it's an Azure website, it runs, got DDoSed. He identified that, he has a little bit of logic in his API. Basically, he put a queue with the IP to block. That message is being picked up by Azure Functions and basically just configure Cloudflare. And on a regular time base, basically, he has the ability to go ahead and clear. The thinking is not really about the architecture, it's the concept of before he had serverless, he needs to work it out. He needs to set up a VM or a container or an Azure Web Jobs if you're running up service. And then he needs to build, patch, and deploy and manage if it's VMs, but instead, even the web job, he needs to build and deploy. You need to monitor that, knows if it's actually running or not. And all of this is even before using the Azure SDK to do put an item in the queue, read item from the queue. He needs to manage the Cloudflare credentials, obviously, and then use our Cloudflare APIs. When serverless, so you take away a bunch of the stuff that you need to do, right? You basically just focus on, hey, the Cloudflare credentials are, as you've seen, like an app setting, so very easy to manage them. You don't need to write code to manage them, that's the thing. And then you need to use the Cloudflare API, which is expected. All right, so what we learned from this is, hey, you have a function, you want to do it one thing, and he actually kept it very precise. Read from the queue, configure Cloudflare, and then a separate API to actually go ahead and clean it up. Okay. Next item is basically if we have timer-based processing. So we have basically something that happened in this illustration, 15 minutes. Go ahead, find some invalid data in a table, clean it up. All right, fair enough. So we have AccuWeather. AccuWeather is a company providing weather services. They're basically using Azure across multiple data centers, regions. And what they want to do is replicate logs from one data center to another. Doing that at the same time, they want to actually analyze the logs, if they're already doing that, and then take action if there's interesting data in the logs. So the way they chose to do it is rather cool. FTP, and they have a timer-based function that basically go ahead, download files from FTP, push that into a blob. Single function does single thing. It's a good practice. A different function triggers from blob, so as soon as detect there is a blob item, it will run. And go ahead, get the data, put it into storage, then run this information on Stream Analytics because there's a lot of data over there. And then, again, a different function will detect abnormal behavior from the stream itself. So that's cool. And again, if you look at the same thing here, very similar to what they need to do. In this case, is an FTP and Azure SDK, but it's pretty much the same thing. So if you had to do a bunch of stuff before, now you need to do a lot less, right? You still need to use FTP library and manage credentials and get the file, but that's about that. So that's not bad in terms of, reducing responsibilities, code, and all that. The nice thing about this example is what we learned, and this is getting a little bit deep into how Azure Function works, but it's valuable information. So when you download an FTP, when you access the FTP, want to download content, you could be facing a very large file or a lot of data. And just by actually being downloaded, you could go over the 5 minutes mark that we have for Azure Function. So Azure Function, I neglect to mention that it runs for 5 minutes. We'll increase that. Right now, it's just 5, but doesn't really matter. The bottom line, even if I'll give you an hour, I wouldn't recommend running for an hour for the next reason, the following reason. And the thing is that if you have a function that needs to run for an hour, what happens if it fails on the 53rd minute? Then you need to run again, so you're almost running for 2 hours. Let's say you would be able, instead of that, because this is a problem that you can actually split shard, whatever you want to call it, you would have a function that would read the metadata of the FTP and then run some very basic algorithm. In this case, they just did it by a single folder, and basically queue message in an Azure queue, which will then trigger a function. But you'll put many queues for many folders, and we will trigger many functions for you to run at the same time. Each one will go and copy its own folder, or small folder, or portion of the data basically. And then when everything is being done and said and done into the blob storage, or one by one, it doesn't really matter. You basically replicate the data and put it in storage, and so forth. This way, if you fail in a single segment, let's say 5 minutes, then you ran for 5 or 6 minutes, all of them, and then you need to run just more those who fail. Make sense? So you shard the information or shard the work. This is basically debatching of processing, very standard in serverless application. A better example, you might have seen this. You basically query for a database. You have 10,000 rows. Now you need to go and send emails to 10,000 people or SMSs, whatever. Usually what we did is we did a for each loop. If we are smart, or if we are a more advanced developer, we might even use thread pool, and on those for each, we will just queue item in the thread pool and let it go clean, but it's still in a single process. So instead of that, thinking of you're going to put 10,000 queue items, and then all of a sudden this backend system will just scale like crazy, clean up all those items as soon as possible. Much, much faster, much more reliable. All right, so function and with that in mind, function should as quickly as possible for that kind of purposes. Async programming, reuse, more reliable, and so forth. This is an interesting scenario, and I'm going to show you a demo for this. Basically, you have stream of data, whatever the stream is, doesn't really matter. This stream is like devices. We're going to show Twitter in a second, but doesn't matter. You have a stream of data. You basically take a function that take the stream, take the data, do some transformation, and just push it forward to the next layer, which is a database in this case, or anything else that we are showing. So with this, we have a Power BI, a sister team to my team. Basically, what they wanted to do is create some sort of example of how can you use Power BI to do some analytics, like marketing campaign analytics or anything like that. So the task they wanted to do is to collect tweets, analyze the tweets, and display the information in a rich way. And the way they choose to do it is as follows. Basically, tweets are being collected through the Logic app and with the Twilio connector. We'll see it in a sec. Then basically this trigger Azure Functions to go ahead and take the tweet information and just break it and shard it and do whatever it needs to do with it, make some analysis, put it into a database, and on top of that, they slap Power BI to basically display the data. Cool? All right, so let's see it in action. This is this. So this is the Azure Resource Group that is responsible for this wonderful thing that we're going to see in a second. You can see there is a logic up here. There is a function. There is a database. The database and the server is standard, basically how we use SQL Azure for the data. There is a Twilio connection here, and the storage account is for the function. So if we really quick go into a logic app, this is really a simple logic app. But as you can see, it runs all the time. It just runs now, or earlier. And it collects tweets. And I'll show you really quick how does it look. It's a very simple logic app. It basically, there is a Twitter connector, and then you just push it into a function. And if I look at the Twitter connection, I'm just looking for serverless, for whatever. Minimally run every 3 minutes. If there are more tweets, it will run more. And you can see here, basically, I'm connected to Twitter with a connection with a Twitter connection. I'll show you really quick how it looks. If I add a step here, you can add connections. And you can see Azure Logic Apps come with a really long list of connectors. Really long list of connectors. Twilio is one of them. You can see there are Microsoft connectors, but there are a lot of other non-Microsoft services, a bunch of services. And it's cool because this is managed API that Microsoft has. Also, you can look at API management, any other Logic app, or any functions that you have. Cool. Okay, so that's ran, and I'll show you the output. So, okay, let me show you actually the function itself. So this is the function, and these guys decided to implement the function with Python, and it's great because it shows that Python can run on Azure Functions. But other than that, it doesn't help because I don't speak Python. And here it is. And you can see basically they are literally directly connecting to the database. They are doing some analysis. You can see they're actually running the sentiment directly in this code versus using cognitive services. Again, their choice is just a sample, bunch of code here. The thing is that every time the function runs, this runs, do analysis, put the information in database. And then what we get is a very rich display that comes with Power BI, as you can see here. And this is just showing basically serverless is right here in the middle in terms of the term. And these are the people that are actually talking about, and there are different clusters of terms and speakers and, people that tweet and so forth. So Twitter has become very popular lately. So imagine what you can do with this tool. You can do other stuff. There are, you can pivot here or overview for whatever reason. I'm not even sure what it means. But you have different authors and different hashtags. You can see all the data and information, 50% unique Twitter. This is how many tweets are in there. And I've been collecting this since basically early October. There's the sentiment analysis that they are running on the serverless. 0 is like, OK, 50% because there's negative as well. So you can see most people are positive, which is good, kind of. So you get the idea. OK, anyway. You see, I have no idea. It's just like a cool Power BI demo. But the nice thing about it is this is how the thing works. All right. So let's think about what they need to do before serverless. And the list is quite long. So obviously, other than the box for running servers, they need to connect to Twitter. They need to use a Twitter API and SDK to get the data. They need to analyze the tweets. They need to build rich client. If I would ask anyone in this room to do it 2 years ago, you'll need to do all of that. And it will be a multi-week project, probably. Today, and as you've seen, you can use sentiment analysis from cognitive services. You don't need to build your own. The only thing you need to do is analyze the tweet. Because we have logic app for the connectors. You get the data. You analyze the tweet. You push it into a database. And you need to build the Power BI view, which is basically just drag and drop a bunch of stuff. Obviously, you need to build a data model, but that's a given. All right, next. So yes, best practices from this. Function should be stateless because the Twitter connector is nice, but tweets get retweeted, and sometimes it fails. And so you need to manage your own item. Your function needs to be its own idempotent and be able to handle when the sender sends multiple messages, because there's never guaranteed there will be only once message delivery, almost in any system. And definitely with Azure Functions, it's the same. And again, every function is asynchronously running from the other. So it's on your responsibility to manage that. OK, so last example of customers. We have customers called Plexure. And Plexure, it's a digital marketing company, basically. And they have built this platform to basically do geo-marketing. So they have an SDK, you deploy it on your application developer build with SDK application, deploy it on a device, or any other swarm of event, as you can see here, from web, from wearables, from point of sale, and so forth. So imagine you drive into a certain area, you get a push notification saying, hey, there is a sale, or there is free lunch over there, and whatever. And they use a lot of Azure services across the board, Stream Analytics, all the data over here. They use functions, and actually they use Logic Up as well. This is the old logo of Logic Up, a small starship, rocket. And I just want to show you what they're doing and how, and maybe it'll be cool. So this is Plexure. I actually they gave me an account, which is nice of them. And what I want to show you is this. So imagine the scenario is like, this is a scenario for when you go into a supermarket, you take a cart, they put a tracer on the cart so it will actually follow you. So as you go along the supermarket, you know exactly where have you been, how long have you been in each aisle, what are you looking at, give or take. And then when you come to the registry to do the checkout, if you use your card, if you use your loyalty card or whatever, they know who you are. So in that case, what they do is basically they're going to analyze your cart and provide you with other options saying, hey, you bought steak, but you didn't bring wine or something like that, right? All right. So the way it works is like if I look into one of those workflows, it's a workflow that they have defined. Behind the scene, this is actually translating to actual Azure Logic App behind the scene. They're just completely obfuscated from their customers. And you can see here point of sale cart analysis. You can see information passing in and through. If you guys would work with Logic Up, you would immediately recognize the syntax. The important thing I want to show you, and they are sending SMS here. The important, and we'll see a login in a second. The important thing I want to show you is that what they have done is basically, they provide an SDK. So their customers, which are also developers to a certain degree, basically go ahead and can create custom code based out of that. And voila, this should have seemed familiar for you guys. They're basically wrapped, because everything is open source on our end and so forth, they have wrapped the editor, they wrapped their creation. They are creating functions on their own subscription, but on customers' behalf. And they're managing that for the customers, but now they have a way to run custom code, which they didn't have before. And this is basically, if I go here again, my bad. This is basically, if you look here, this is just an Azure function that they're using, which is pretty cool. And if you look at their, experiences and workflow, you can look at logs, and you can see like all the traces. It's basically pretty much the same thing I've shown you guys thus far with all the information in and out. All right, I think we're getting very close with even a few times for questions. So again, in function programming model best practices, you want to make sure that your function is doing one thing, easier to debug, easier to maintain, more robust, basically sort of programming or long term. You want your function to finish as quick as possible. Talked about it. Definitely have it stateless. It's not a must, but it's highly, highly encouraged. Definitely under the fact that if you're running at scale, we guarantee nothing on where you run. And we can have one instance of your function running on VM1 and a different instance of your function running on VM 101. And they cannot talk to each other. So don't maintain state within a function. Not good. And idempotent is a good practice for APIs in general. OK, so Azure Function, yeah, I think it's awesome. Yay. It's a baseband serverless compute. As I said, all the demos you've seen here, there are server behind. Serverless is a horrible word, but to describe serverless. But basically, the fact that there are servers there, you really shouldn't care that there are servers there. It abstracts away the infrastructure. It abstracts away the services, I/O. This is the binding comes into play. And it offers a serverless programming model that if you buy into it, you can build really rich application. And I think with that, kind of done. You can try functions if you have Azure. If you have an Azure account, just go ahead and do it in the portal. If you don't, you can go to aka.ms try functions. Same thing with try app service. Go ahead and try app service. And with that, I think I'm pretty much done. Thank you.